Welcome to the short demonstration of the SIMIO Digital Process Twin solution. Our vision is to become the leading process digital twin solution for improving both the design and operation of complex systems. So what does this mean? The tool can be used to answer the design type questions on the left with a simulation model only. But if the model is built to be used operationally, it can answer the questions on the right-hand side by producing a detailed plan and schedule. The same digital twin can then be used back and forth to answer design questions and do what-if scenarios, while also be used operationally on a day-to-day basis to produce a detailed production schedule. We will begin the demonstration by looking at a real customer model. The first thing you should notice is that the customer brought in a CAD drawing of their facility. This was important because as we laid down the objects that represent machines and trucks, everything is drawn to scale. This particular model is scheduling tasks for the trucks. So where does the truck need to drive next? This model is rescheduled multiple times throughout a shift based on different events that happen on the shop floor. SIMIO can react to machines breaking down, the temperature of a crucible changing, etc. The important part about the 3D in this model was that this customer used this as a training tool and also a change management tool. While they don't use the 3D animation on a daily basis, it was important to help get the buy-in from the operators on the shop floor so that they trusted this new schedule and they would in fact operate and execute to it. Once the customer saw the animation and started trusting this model, they realized that in addition to using it to create their detailed production schedule for every shift, they can also use it to answer questions about capital expenditure purchases. For example, they were interested in purchasing a new truck that might cost millions of dollars, and they used the model to do some analysis on whether or not that was a purchase that would produce the ROI that they expected. Let's transition into another model to show more of the scheduling functionality. This model is based on a current customer's production. In this case, we've called it a candy model that produces 3 different types of candies: barrels, balls, and disc. Within these types of candies, there's also different types of flavors and different recipes. This is important because we want to demonstrate the fact that we can handle scheduling based on attributes. So the routing of the parts might change, the changeovers might change based on either flavors, or the tooling might change based on the type of candy we are producing. There are other special labor rules and complexity within this small sample model. This model contains rules for how a part is selected to be produced next on a machine. It also contains rules about which parts can be produced on which machines more efficiently. Like all SIMIO models, this model's logic is driven from data. We're going to first look here at the materials table, which defines raw materials or finished goods, bill of materials, manufacturing orders, which specifies each order that needs to be produced along with the attributes of that order and the due date, and then routings for each order. So how do they route through the system? Additional information such as which machines can and cannot produce each part, and if there's additional labor requirements needed for that particular routing. All data can be bound to an external source, such as an ERP, a manufacturing execution system, or any other database or file. And this is done table by table, and it can be set to automatic so that every time the model or the detailed schedule is run, the data from the external system is brought into the model. When you are ready to plan, you click on the Planning tab and click the Create Plan button to create a detailed production plan. Running Analyze Risk will then run the replications that you've specified here to do a risk analysis of the schedule. The resource Gantt that we're looking at is one example of the output of the detailed plan. We're going machine by machine to understand which orders have been scheduled on which machine and for how long. We can also look at information such as this striped bar to see order number 7 is waiting on press machine 3, but it's not processing, and it's constrained by certain things. And if we open up and look at constraints, we can hover here to get an understanding that in this case, it's waiting on a worker. It cannot process on press machine 3 until a worker is available. We can also take a look at the tables to get an understanding of all of these manufacturing orders. And if we scroll over and we look at the dates, we can understand which orders are expected to be on time and which orders will be late. The risk assessment then also gave us a probability or a risk. So for example, this order says that it will be on time if everything goes correctly. However, the risk analysis says that there's only a 78% chance that this order will be on time. If we filter this table down to late orders, you notice that we still have 3 late orders. What can we do about that? Well, if I draw your attention to the right, this model currently is using a dispatching rule of first in queue. And that means that the machines will always just choose the order that is waiting first in line. We can change this and we can experiment with how this might improve the model. So for example, we might try minimizing setup time. And then what we can do is we can come back and we can rerun the plan to get an understanding of if we have fewer late orders. If we look at the results, we still have the same 3 orders. However, our costing is less, which makes sense since in this case we are trying to minimize setup time. Instead, if we want to try to get our late orders addressed, we might choose earliest due date and rerun the plan. And if we don't want to do this manually, an option would be to set up an experiment and experiment with which dispatching rule will give us the best results. And we'll talk about experiments in a minute. Notice earliest due date did improve, but we still have 1 late order. So if we come back to our properties, we can then change this to say, let's first go with earliest due date, but then let's have a tiebreaker rule to say largest priority. And then when we come in here to our model, we can change the priority of this order to a 2. And then when we rerun this plan, what we're going to see is the fact that both of these 2 dispatching rules working together gives us 0 late orders at this point. So if we uncheck this box, we can get a holistic view of all of the orders that are now on time and also look at their probability. If we then want to look at experimentation, as mentioned earlier, we come up to the top right and we can set up a design of experiments either manually or we can tie in an optimization tool to help us create the different scenarios. So we would define the input parameters and we would also define the outputs or the KPIs. The inputs can be whatever you would like, and you could vary things like labor, how many workers do I want to have on shift? You might experiment with the different dispatching rules that we talked about a few minutes ago, or any other areas of the model that you can change in order to vary your KPIs. In this case, we're using OpQuest, which is an add-in, but this is where our API is open and you can tie in any optimization tool that you would like. When you run the optimization and then you find the scenario that meets your needs, you can then just simply right-click and say, copy this particular scenario's control values into the model, and then you can rerun your plan or your schedule. Another example of an output of the detailed schedule are dashboards. These can be customized for each model, and one example would be a dashboard for your orders and which ones performed on time and which ones were late. You can build a dashboard about your resources to get an understanding of which ones were idle, busy, starved. You can also get a dashboard for your raw materials or finished goods so you can see how they behave throughout the schedule, and a task list to get detailed information about each machine. Now that the production plan is created and it's manipulated so that the planner is happy with it, the question becomes, how is it deployed down to the shop floor and out to anyone else in the enterprise? We're very flexible and do what our customers want, and it can be anything from the extreme of producing detailed custom reports or dashboards and then printing those. So we can create anything from a dispatch list for a worker, for a machine, all the way down to a truck. And these can be printed and handed down to the floor. More often than not, the schedule is deployed electronically, and that could either be down to another system, such as a manufacturing execution system, or it can be published up to a website. And SIMIO has their own portal, which can be deployed on a on-prem or a public cloud. So if we want to take a look at that portal, this is what the SIMIO portal looks like. And there are plenty of features on here, but we're going to look at what it might look like to have a plan or a schedule that's been published up here. And what you can do is view the results of this plan. So this could be anyone who's sitting in a corporate office, or it could be the folks on the shop floor, and they have access to all of the dashboards, all of the log files, any custom table reports that were created, and of course the Gantt charts. So if we click here into the example of the big Gantt chart that might be deployed on a large screen, you're going to see that it looks very similar to what we were looking at in the desktop version, so that the operators on the shop floor can get an understanding of what they are executing to. So in summary, you've created a detailed simulation model of your system that can be used to answer design questions and do what-if scenarios. But the same exact model, when tied to real-time data from your ERP or your manufacturing execution system or any other system, can be used as an operational digital twin, looking forward and creating a detailed production schedule. This detailed production schedule is different than any other production schedule because, being a simulation model underneath, it can capture all of the constraints, whether that's constraints on labor, tooling, raw materials, or any other resource. The other power of the simulation is the fact that it can provide that risk analysis, so you can get an understanding of the riskiness of your schedule, whether that's the risk of on-time orders or the risk of meeting your budget. For more information, visit our website, where you can find information about how SIMIO is deployed in different industries through a number of case studies.